Hey guys, this is Unit 4, Video 7. We're going to be talking about ionic radius in this video. So kind of piggybacking off of our last video, which was on atomic radius. It's going to be very, very similar to it, but we'll see that how it differs. So on page 18 in your notes, ionic radius, we're going to abbreviate it as IR. Okay. So I want you to think about ions. Okay, so we have two types of ions that we've talked about. We got positive and negative. All right, so we're going to kind of split it up into kind of two different pieces with it. We're going to talk about the nonmetals and we're going to talk about the metals when we talk about ionic radius. So again, same idea. It's going from the nucleus to the outermost electron, but now with ions, something's happened to those electrons, right? They've either gained electrons or they've lost them. So we're going to start with nonmetals first. Okay. So nonmetals tend to gain electrons. Think about where they are. They're to the right of the staircase. So they have 5, 6, 7 valence electrons already, and we're trying to get to 8 as our magic number. So it's easier for them to gain 1, 2, or 3 electrons versus losing 5, 6, or 7. So it should make sense that, hey, nonmetals, they're going to have a negative charge when they form ions. Now, since they're gaining electrons, they're pulling something in. Think about it like this. If you were to add $1 to your wallet, is your wallet going to get bigger or is it going to get smaller? It would be getting bigger. Very simple idea of thinking about it in terms of that. If you're gaining electrons, you're putting them into your atom, they're going to get larger. Okay, so the radius is going to increase. Now, the real reason why is that you have the same nuclear charge. Oops. Okay, now think about it. That means you have the same number of protons pulling on a different number of electrons. So same protons pulling on more electrons. Think about it. It's a battle, right? You've got positive and negative charges. Well, if you have the same number of positive charges and then you add other negatives, they can't, even out. Okay, so the electrons outnumber the protons. Therefore, the electrons will drift farther away from the nucleus. They start to spread out more. Okay, it's like if you have, a parent that has 3 kids and trying to control those 3 kids, and then you add another kid or a friend into the mix, well, then there's more, so they're losing that battle. Okay, they're going to lose that battle. Same idea here. So nonmetals, they're going to gain electrons, their radius is going to increase. Metals will be the opposite. Okay, they're going to lose electrons. Think about it. Look at their charges that they form. Think about how many valence electrons they have. Metals are to the left of the staircase. They have 1 valence electron, 2 valence electrons, maybe 3. And again, they're trying to get to 8. So is it easier to gain 6, 7, 5, 6, 7 of them, or is it easier to lose 1 or 2 electrons? And it's going to be easier to lose them. They're very readily giving those up. So therefore, their radius is going to decrease. Okay, again, reason very similar. And you've got the same nuclear charge, so same number of protons pulling on less electrons. So think about it. Go back to that analogy we had of a parent before. All right, they had 3 kids, and now 1 kid goes away. So now there's 2. They can rein those in and kind of keep track of them a whole lot more. So the protons outnumber electrons in the metals case. Therefore, the electrons are pulled closer to the nucleus. The positives are going to start pulling them in like a stronger magnet. Another reason to think about, okay, is that metals, they're going to lose an entire energy level. So if I were to draw right here, sodium, okay, in the center we have 11 protons, we have 12 neutrons. If we were to draw the Bohr diagram, I'm going to run out of space here, so you guys can make sure you have enough space. We had 2 electrons in the center, or in the first energy level. Then we had 1, 2, 3, 4, 5, 6. I know this isn't correct, but it's just to show. Okay, there's 8 there, and then there's 1 here. So now when it becomes an ion, it's losing this guy right here. Okay, it's going to get rid of that. So now, look what we've effectively done. We still have those kernel electrons. They're going to be the same. Right, so we have 2 in the first energy level. We have 8. I don't know what happened there. We had 8 in the second energy level for a total of 10. So we lost 1 electron. Well, look what else we lost. We lost an entire energy level. Okay, so that's another big reason why the cation, or the positive ionic radius, is going to get smaller, because you're losing an entire energy level. Okay, so keep that in mind. Where if we go over here to magnesium, same thing. We now have the same. We lost our 2 outer electrons, but this is going to be very, very similar to sodium. So when we look at those ions, those cations, they tend to have the same Bohr diagram, the same number of electrons. They both have 10 because they started with different numbers, but then they want to lose it to get to that stable 8. So now these 2 ions that we have pictured here, they're going to be considered stable because they have 8 in their outer shell. So that brings us to another term, this thing called Isoelectronic Series. All right, and that's where we have atoms and ions that have the same number of electrons, total electrons. What other element, guys, has the same number of electrons that these two have? Think about that as we go through. So elements gain or lose electrons in order to attain the electron configuration of the nearest noble gas. Again, that's what they're striving for because they're so noble. They want to be part of that family. What makes them noble? Again, it's that stable, that full outer shell. And full meaning 8. So they're trying to get to 8 the whole time. All members of an isoelectronic series have the same noble gas configuration. So for example, the nitrogen ion, oxygen ion, fluorine ion, sodium ion, and magnesium ion all have 10 electrons. If you don't believe me, go ahead and count them up. Okay, nitrogen starts with 5, it gains 3, therefore it's got, starts with 5 valence electrons, starts with 7, gains 3, ends up with 10. Oxygen has 8, gains 2, ends up with 10. Fluorine 9, ends up with 1. You get the idea. So they all have the same electron configuration as the noble gas of neon. All right. So just to kind of recap, okay, 2 big things. Ionic radius, similar to atomic radius. Nonmetals gain electrons, they're going to increase. So your anions are going to be larger, cations are going to be smaller. So we can kind of jot that down up here. So cations, well, let me change it. Do it over here on the right. So cations are smaller, anions we're going to be larger, okay, and then isoelectronic. Okay, they're going to have the same configuration as the last or nearest noble gas.